Hey guys, I'm Phil Lombardi, and I work for a company called DataWire.io. It's a little tiny startup up in Kendall Square. Basically, we're building out a microservices communication platform, but we decided to build this ourselves by doing the microservices. And it's generally an inadvisable thing to do as a startup to start doing that. But since we are building a platform for microservices, we kind of said we'll dog food ourselves. It's an open system, but we had to figure out how to deploy these services pretty quickly. When you have basically myself and one other developer, and we're just moving pretty, want to get things out, we want to have a pipeline, they'll basically test our code, build our AMI, and then deploy that code seamlessly. And I mean, there's a bunch of different strategies out there for doing this, but the simplest one that exists is really the good old blue-green, which is basically put it up there and then switch it out. So that's what we decided to build. It's basically, we're doing it with Travis CI as our building engine, so we've decided to avoid doing anything with Jenkins, just because it's too complicated. It's also a major pain to set up and administrate yourself. We elected to choose blue-green in the first place, mainly because it's pretty simple to conceptually understand. You're going to have two clusters running at any point in time. Well, actually, you're going to have one cluster running at any point in time. You're going to have one load balancer coming into it, and you're just going to swap. And the nice thing about it is, in a case where things are moving quickly as a startup, people make mistakes. If you, for whatever reason, need to roll back, it's really easy to just kind of go, all right, we'll cut from the green, which is the new guys, back to the blue, and we're good to go. And there's minimal downtime, minimal impact to our customers, and at the end of the day, it kind of looks good to us. So that was the reason for adopting. Our flow is pretty simple. It's standard kind of pipeline. Developers commit to GitHub. We work on both branches and a master. Travis picks up the changes that come through GitHub, and then it builds them. We run simple unit tests. It's actually a combination of Java and Python, so some services are written in Java, some are written in Python. We're looking to introduce Go at some point. Hit some tests, and then we have Packer goes off and builds this stuff for us. It turns it into an AMI, which is basically our deployment artifact for everybody. Those AMIs get stuck in the repo, and then we do this thing as a swap. And we use Terraform to handle the swap. So Terraform handles all of our infrastructure for us. We've set it up so that everything is represented as basically a module that a developer needs to deploy their service. So an ELB is generally what their incoming endpoint is, and then we have the two clusters behind them, the blue and the green. And we use Terraform by keeping just a color in the Terraform state file, also associated with a variable in the var file. And we switch it from blue to green. That causes Terraform to go off and change things. There's a little Python script called swap.py that just updates that variable, changes the size of the blue cluster to 0, changes the size of the green cluster up to the same size of the green that the blue cluster was, and then we hit Terraform apply. Usually, if they're not making any kind of infrastructure changes, that's no issue, it's just an AMI change. In a situation where they do have to kind of make some infrastructure changes that are going to cause more complicated Terraform changes, we actually kind of inspect the changes before they go out, but usually it's not an issue for us. So that goes out. So I don't know how familiar any of you are really with blue-green. Like, how many of you guys actually do it in production right now? So the flow is basically, there's a couple ways we can do it. The flow we use is we have a load balancer. There are two auto-scaling groups sitting here, which are have a bunch of EC2 instances behind them. In the first model, you have V1 on blue. All ELB traffic goes to blue. And then at some point, you decide, I want to upgrade, so I change the launch configuration that the green cluster is talking to. Still, all traffic is going to blue. We scale up the green cluster so it matches the same size as the blue cluster, so it can handle the traffic that's already going there. At that point, we basically then connect the green cluster over to the ELB. So now traffic is actually flowing to both the blue and the green cluster in parallel. This allows us to kind of see gradual impact with that change, see if it's going to work. Usually it does, but in the worst case, we can just cut it off immediately and say, go back to all blue traffic. For a little bit it runs like that, and then we start to basically stand by blue, which basically starts to put all the instances into kind of what you call finish up your traffic as quickly as you can, and then we're going to cut you down. At this point, the ELB is no longer routing anything over to blue, it's all handing it to green. And then we disconnect blue from the cluster completely. We do a little bit additional monitoring as well during this period of time. just to make sure everything's good. And then finally, we downscale blue completely, just let it go. But the nice thing is, blue is still there in theory. So if, we continue to go green for a couple hours, whatever, and then we discover some showstopper critical bug, we can then spin back up blue to the same size it was, cut the traffic back over, and we have a known working stable version that was there in the first place, which is really nice. Which is really, really nice. I was actually going to show a demo, but I didn't know how much time I was going to have. So instead, I decided to just share with you my sample GitHub repo where I put this project together. I've included the configuration for the modules for the various Terraform components. I've also included the swap.py. It's a modified version of the production one we use, a little bit stripped down. It doesn't have some things like basically the health checking that we would do to make sure the service is working properly. It doesn't have some of the monitoring stuff in there, but I've commented where that would be if you had to want to put it back in yourself. And yeah, check us out. Check out our organization. Check out the repo. Send me an email if you have questions or throw me a pull requests. And, yeah. Oh, we're hiring too. If anyone wants to come work for us. Yeah. Any questions?
How long does it take you to spin up an entire green cluster, for example?
It doesn't take that long, so we can do it within 5 to 10 minutes usually. Mainly because everything's already baked, so when we deploy those instances, there's very little actual post-deployment work that has to be done. We use CloudInit usually to pull down maybe a config file or something for a service, but every single instance is already baked at that point with the code it's going to run. Most of the hard configuration it needs is already there. So if it has to deploy anything, it's like secret keys and it's going to be config files.
How about building that?
Building the AMIs. So from code check-in to building AMI, it's about a 10-minute process. So the AMI bake takes about 7 minutes best, running all the tests. We try and execute as many unit tests as quickly as possible. On Travis, I would say, for my services, I get code built in about under 60 seconds, unit tests run, and then acceptance tests run. That's about 3. Then Packer takes 6 to 7 to 8 minutes, and then that's when you have your AMI ready to go.
So 20 minutes altogether?
Yeah, it's about that.
Cool.
So you're heavily reliant on compatibility between the blue and the green environments, unless, you have sticky sessions?
We don't have sticky sessions, no. But if we did, yes, there would be a problem. So there are strategies for dealing with that. Sticky session would be one, but for example, take a system where you have a stateful service. It may not work blue-green to spin up a whole new cluster. And say you have a database backing this thing, it's not reasonable to copy it. You probably have to pick a different deployment strategy at that point. So a rolling upgrade is another typical approach there, or some other one where you actually just go back over the cluster and re-provision and stuff is another problem. It's not a one-size-fits-all.
So one of the issues, we were doing something similar. One of the issues we had when we had split, like the middle path was both blue and green. Our app is essentially a web app, and we serve a bunch of precompiled assets that the version that's being used in the browser to hit the backend actually is tied to the version of the backend. That design, whatever we're working on it. But basically, when you have a browser with new assets hitting old server or vice versa, old assets hitting new server, is that the scenario you're talking about?
Yeah.
But even ignoring data storage, just have incompatible sequence of requests, one going to a new version.
You often need to resort to things like feature flags in that case, and basically if-elsing the code all over the place.
But that still doesn't.
What's the structure of your app? Sorry.
No, I just saying we're working on some of the same problems. It also goes back to data migrations. It's kind of the same issue. So I think what he was referring to with feature flags is you going from a back end of version 1 API to version 2 API. What you would do is do a blue-green deployment that would just deploy the version 2 API with no front-end stuff. No one can use it yet, but it's already there. And then the next deployment changes your front-end assets to now point to the
We're a Rails shop. That would have been awesome if we're a Rails shop. They go together. And you split your backend API servers deploys from asset deploys?
No, as I said, with the feature flag, we deploy them but no one can use them yet until the V2 API has already been there for a deploy. Right, so the V2 API is there for a deploy.
Yeah, understood. You're kind of just trying to think how would it apply to us because we're messy.
No.
Always a challenge.
Yeah. Paul?
So yeah, same idea too, like how do you do that with SQL databases? I've tried that in the past, and the way I kind of got around that with having colliding primary keys is using VUIDs. So have you had any strategies like that to like migrate the entire database to a new version?
I've actually not tried to do this with the SQL database, so I
Okay.
don't have a good answer for that.
Okay, thanks, Phil. Okay, that is the end of our program for tonight. Thank you for being patient. We went a little long. Thanks to Cody and Zipcar for hosting us.
Dig swag.
Yes, there is swag over here if you want to grab things.
Excellent.